So JoeBen, let's begin with you. What's your vision for daily mobility and what this is going to be like? People, just paint the picture. Where are we going?
Yeah, this is it's a magical moment and really enabled by electric propulsion. It allows us to fundamentally rethink the architecture of an aircraft and allows us to create aircraft that are really massively superior to any aircraft that's been built before on a range of different dimensions. So the first of those is the safety. We can architect these aircraft, small aircraft, with redundant systems that provide incredible levels of safety. Second, acoustics, allowing these aircraft to land very proximately to where you want to depart from and where you want to go to. So we envision being able to take off and land from rooftops. And then finally, the economics. Right now, commercial air transport is incredibly cost-effective mode of transport for long distances, but it's very expensive for short-distance travel, and so we don't use it on a daily basis. We're stuck to surface transportation. And so if we can envision a future where we're flying every day to where we want to go, it allows us to really profoundly rethink society and the cities, the layout of our cities, allows us to rethink real estate. So it's a really exciting future that really moves transportation and daily mobility into the next century.
We'll drill into some of those things later, but Uma Subramanian, tell us where this is happening and how far in the future is this?
Yeah, so for me, the reason electric propulsion and urban air mobility are so interesting is studies show that by 2030, 5 billion people will live in the world's cities, so 60% of the world's population, up from about 45% of the world's population today, which is a material jump. So the next decade is forecast to be the greatest period of urban migration in human history. And if you look at what's happening in the biggest cities in the world, in Mexico City, in Sao Paulo, in Lagos, in the cities in China, ground infrastructure, as currently configured, can't keep up. So most of the carrying capacity is already accounted for. And so you've got two choices. You can take the sort of boring company approach and dig, which is very expensive on a per mile basis, or you can take to the sky. And so for me, what's really exciting is that we're at a point now where you can architect a city in a radically different way. And so the company that I ran, Voom Flights, an Airbus subsidiary, recognized that electric VTOL technology, electric vertical takeoff and landing technology, in the spirit of not using too many acronyms, is coming, and it's on the horizon. And at Airbus, we were working on a number of different projects to try and build next-generation electric VTOL aircraft. But in the short term, you have a technology which is underutilized today, which are helicopters. And so the business that I ran was about using helicopters today as a precursor for electric VTOL technology to enable people to move in cities through the sky. And so the regulatory environment outside the US is pretty favorable for a number of reasons that are perhaps not politically correct, but you can test a number of different technologies and technical solutions in those markets. So Sao Paulo is the ideal city. So we launched in Sao Paulo in 2017. Sao Paulo has 700 helicopters and 400 rooftop helipads. And we were able to fly up to dozens of passengers a day in the city and really explore how you can unlock the urban sky with this technology.
And is that because there's sort of that sounds like an ultra wealthy thing? There's a lot of wealth disparity there in Rio.
It's not. We were actually priced. Oh, the reason for the helicopter density in the first place?
Or just the fact that it's lacks regulation and wealthy clients. Yeah, is that part of it?
It's actually very well regulated. So they have a dedicated helicopter traffic control. The city was actually built and zoned for air transportation as a precursor. And so the city that had a regulation which buildings over a certain height all had to have helicopter landing pads.
Okay.
And so it's kind of the perfect place, specifically focused on Sao Paulo, is the perfect place to enable something like this to happen. Los Angeles was also zoned for this, but they recently removed that requirement. So in Brazil, at the moment, you've got the right kind of confluence of a favorable regulatory climate around this technology and the infrastructure to support it.
So Jennifer Richter, in Washington, D.C., what is the regulatory environment and what are the FAA and FCC doing? What are their roles looking at these things?
Wow. That's a lot of questions. Where are we? We just recently achieved the first authority from the FAA to allow Google to do package delivery. And so this is UAS, unmanned aircraft systems, lower to the ground, drones that are not carrying people, but packages. That took a lot to get done. They filed for 70 plus waivers of the current manned aviation rules in order to get that authority from the FAA, and that's only allowing them to deliver packages within the visual line of sight. So it's pretty limited still. The regulators are struggling mightily to figure out how do we enable all these great technologies in the systems that we have, and it's going to take some time to get done. For sure. And that's just UAS, again, package delivery. That's not putting people on drones. I will say the conversations that we have with all of the regulators about the future here and about urban air mobility is really encouraging. And they see the vision and they understand where they need to get to, but they're just, there's a lot to work through before we get there. The different roles of the government agencies is interesting. So the FAA really looks at all of this from a safety perspective. The FCC has a role because you have to be able to communicate with these unmanned vehicles that are flying in the air. And so the FCC looks at this from a technology coexistence point of view. The wireless networks will be used to help support the communications functions of UAS and UAM. And that's
minus what UAS and UAM.
Yep,
Yeah.
unmanned aircraft systems, so drones, and urban air mobility, automated air taxis carrying people. The FCC is looking at how do we allow the wireless networks to be used in the air and on the ground simultaneously, and is there any technology coexistence that we need to figure out? Is there any interference that might occur? The Department of Homeland Security looks at this from a security point of view. What is safe in terms of our military bases and our critical infrastructure, and should drones be allowed to fly anywhere, and what do we need to be concerned about? And so remote ID and tracking of drones is super important and really a building block for everything that we're doing here. And NASA is working on this UAS traffic management system. They've been so ahead of the game and doing such impressive work. And remote ID and tracking is necessary before we can have a whole system that's going to help govern where drones are in the airspace, and then matching that up with where manned aviation is at higher altitudes. So there's a lot going on. And I say, we've been working at this for 6 or 7 years, but we're still at the beginning. There's a tremendous amount left to be done.
Charlie Vogelheim, there's some things come in cycles, and there's actually some of these things have existed before. There was something called San Francisco helicopters, which operated from 1961 to 1985. Tell us about that and what it cost and why it went away.
So SFO helicopters worked here in the Bay Area and flew daily flights, up to 100 a day, from Sausalito, from the Ferry Building, Oakland to San Francisco. You could check your baggage right through. It's $4.50 for an adult, $3.50 for a kid. And imagine 100 flights a day with these large Sikorsky helicopters flying around. Depending who you talk to, it didn't work out in the end. It was not necessarily profitable. They had contracts with the post office, but they were listed in the airline guide, and you could check a flight right on through and connect with your TWA or American flight at SFO. I think about it when I think about this location where we have here. I spent a lot of time with its development of autonomous vehicles, the possibilities of that, and I see with the Bay and how congested that makes the area, but it also gives us this big area to transport ourselves over without anyone underneath, and wonder what that means in the form of, again, safety, form of noise, in the form of visual pollution, that type of thing. So, but we've been there already.
Uma Subramanian, tell us about the relationship between autonomous cars and these drones. How much was there technological overflow from what's happening on the autonomous cars to what's happening to autonomous vehicles? Well, maybe they're not autonomous, but tell us about the technology relationship between cars and flying cars.
So I think an important kind of point to make is that we don't believe that UAM is going to be the only solution. but it's going to be part of the solution. So you're going to have autonomous vehicles on the ground coupled with urban air mobility, coupled with better public transport, and collectively those things are going to work together to bring relief on the congestion issues. But from a technological point of view, and I think JoeBen's probably really well placed to discuss this, but you've got the same three systems that govern autonomy on the ground. So you've got LiDAR, radar, and cameras. And so they just work in different proportions in the sky because the distances that you're measuring and the rates that you're traveling are materially different. And so while the technology is similar, you could argue that the problem is slightly easier to solve in the sky because you have far fewer things that you can interfere with. But JoeBen will probably disagree and say it's probably harder to solve in the sky. But it's an interesting, so the basic technology building blocks are the same, but the control algorithms and the things that make them work together are materially more complex.
There's a lot of sociology I've learned at a four-way stop in terms of cues. Is that person
waiting?
What does that nod mean? Are you going? Are you stopping? Right? Are you going to hit me? Am I going to hit you? Right? There's a lot of sociology at a four-way stop. JoeBen, is it true that there's less of that in the air, or is it harder?
Absolutely, I completely agree with Uma that the autonomy for these sorts of aircraft is a simpler technological challenge than for ground vehicles. But there's something that's even more exciting, is that we don't need these to be autonomous in order for them to be profoundly impactful for all of our daily lives. So autonomy does allow us to reduce the operating cost of these aircraft, but whether that autonomy comes 5 years, 10 years, or 15 years from now, we're still going to be operating these aircraft within the next few years. So we're able to operate them just like a small airplane or a small helicopter is operated today, with a pilot within the existing air traffic control framework. And that's really exciting for the FAA and for the regulators because that allows them to embrace this new technology, which is going to really fundamentally change daily mobility with the existing rules and the existing framework. And so the FAA is really leaning in on this, and they're applying a huge amount of resources to make sure that they're not the slowest part of the program.
And we are finding that with collision avoidance technologies in particular, the technologies that have been invented for ground use to keep cars from colliding is often thought about for use in the air to assist with collision avoidance. And so the CV to X component of LTE chipsets is something that we think will work efficiently on the ground and in the air.
Yeah, absolutely. All of the technological components, whether it's, as Uma talked about, the LiDAR or the radar, the cameras, and all of the algorithms that fuse that data together are very, very similar. And so we've been able to piggyback on a huge amount of work and a huge amount of research that's being done for autonomous ground transportation. But again, the long pole there is likely going to be the regulatory one, as Jennifer was talking about. Getting autonomous aircraft into the national airspace takes new regulations. And so there's variability on how long that will end up taking. And so that's the reason that bringing this to market as a piloted solution in the early days makes a lot of sense.
And is this a federal question at first? Is this going to be the federal government that's deciding this? It's not going to be Arizona deciding, there's been sort of this scramble with autonomous vehicles with Arizona, it's crashing California. Arizona says, come on, bring them over here, no problem, right?
Well, there isn't a state that hasn't tried to legislate with respect to unmanned aircraft. So the states really have gotten into the act. The FAA has tried to make clear that they have sovereignty over the airspace, but state and local governments can create their own rules around privacy and nuisance and those kinds of features that the community may be concerned about.
And I think generally in most countries, airspace is governed at the federal level. It's very rare that it's a kind of local jurisdiction.
Charlie Vogelheim?
Well, a good way to think of it, the FAA allows you to come into the air, and then it's the community that allows you to come back to the ground.
That's true.
So that's where the so it's a good thing to have. I'd like to just go back a little bit because you mentioned about the cars, and just remind everyone that we're at this crossroads where there's four things that are kind of a problem right now we have with transportation: congestion, pollution, mobility, just the ability to get into those that are getting older, and even safety. And this is what this autonomous vehicle development is trying to solve. But what we don't solve with what we call ACEs, which is the development of autonomous, connected, electrification, and shared vehicles, necessarily is the overall congestion issues. So then all of a sudden the idea is to take to the sky. And we can do that with this technology, and even if it is piloted and we have the sensors in there, the collision avoidance and things, it makes it either for an easier craft a safer craft, or possibly less training required for the pilot. So.
But roll back the clock 5 or 10 years, Charlie, and Uber and Lyft sold us on the idea that shared was going to solve congestion, right? It was going to reduce car ownership. And I think John Zimmer, founder of Lyft, was very sincere about this. Looked at this asset that we have that's used 5 or 10% of the time. It's sitting there. You're paying insurance. You're paying for parking. All this time you're not using it. It's an underutilized asset. It made sense. So let's share it. And then the unintended consequences is that it increased traffic congestion because 40,000 cars come into San Francisco every day from far away to be around because we want them to be there less than 2 minutes or else we're upset. And we're unhappy. So, that was what we were told before, and it actually was. We were sold that it was going to reduce congestion. It's increasing congestion. So, why should we believe it's going to be different this time in the air? That's going to do what as promised.
Well, I can't make that promise, but what is interesting about the airspace is that it is massively underutilized, and so right now the airspace system in most countries is a nodal network. And you could put many, many, many more multiples of vehicles through that nodal network before you reach any kind of capacity constraint. And I think what is interesting about the airspace utilization is that while you may get there, so Uber Elevate talks about a network where you have 1,000 vehicles per city, which would be great for JoeBen's business. But it requires a leap of imagination because we were flying 4 helicopters in a space, and the ground control infrastructure considered that space congested. So there are many multiple iterations of vehicles that can come into an airspace before you get anywhere near the congestion that you have on the ground.
Are you assuming that they're quiet and unobtrusive and that they're not peeking in my window while I'm changing? And
hopefully they're not flying that low. We've got a bigger problem.
But social acceptance, right? Jennifer Richter, that presumes there's social acceptance, right? There's one thing that's technologically possible, but then there's social acceptance, which I know you think about a lot.
Yeah, absolutely right. Well, there are two things that are really important. There's community acceptance and community readiness, which are really two separate things. So we do need to get communities comfortable with seeing a lot of vehicles flying in the air, low to the ground for various purposes. And, I think Uma was talking about the Voom model as something that's really been a precursor in some cities to allow people to start to think about taking to the air rather than the ground to get where they need to go. So that's really exciting. But we do need to work through the noise issues to the extent they exist, and the privacy issues because people are concerned about that. That seems to be a hot button people like to push. And we need to work through other issues like counter UAS. There are a great many issues that we need to work through to make sure the communities are comfortable with this innovation. But communities also need to be ready because we need to think about them as partners to, Joby Aviation and Airbus and Uber Elevate. The communities have to invest in the communications infrastructure that will make their cities smart and make their cities capable of supporting the low-altitude traffic management system that needs to be on demand and available and reliable all the time in order to support safe flight. And that requires dense fiber and small cells, dense wireless in these communities and lots of sensors. There's a lot that goes into this, and the communities really need to want this and to be an active partner.
So Charlie Vogelheim, why should taxpayers invest in dense fiber and the infrastructure for a few rich people to fly around in the sky?
Well, again, hopefully done right, it's not going to be a few rich people. It's going to be a viable solution that's going to be not only for people, but also for commerce. There won't only be, again, flying you around, and you think about any time, even in emergency situations and things like that, to get from point A to point B. It's all about infrastructure. It's an infrastructure cost. I mean, we've paid for airports for years. We've paid for the whole ATC, the air traffic control system, and everything about that. It's part of our transportation network, whether it's, again, the municipal buses or the roads that they go on. It's all part of the cost of another form of transportation.
JoeBen Bevirt, a lot of products, cell phones, start out as elite products, and then they go to the mass market. Tesla did that with electric cars. Now, you can buy an electric car for $30,000. What's your vision for going from elite to mass?
So we really want to be able to launch this at an affordable price point that's accessible to everyone. That is similar cost to taking a taxi on a cost per passenger mile. And then our ambition is to get it to the cost of personal car ownership. And so that's what you can achieve as you move towards autonomy. So
this really is Jetson. We're going to have one of these in our own garage. I mean,
again, this is you're buying a ticket. You're booking it like you do a rideshare, ground-based rideshare, but instead you're going to get there 5 or 10 times faster. And so that's the essence. But it is all predicated on utilization and sharing the aircraft.
Expensive as at first, but the price will come down just as Uber and Lyft started higher and they came down, right?
But again, in the price of a taxi, as an entry point.
And JoeBen, explain why electrification is key to this, because this is Climate One. We want to talk about displacing fossil fuels.
Yeah, so one of the big challenges with helicopters is they're incredibly noisy. And I don't want a takeoff and landing, a helipad sited on the building next door. And so in order for neighborhoods to ask for and embrace this, because as Charlie talked about, the airspace is regulated at the federal level, but the takeoff and landing locations are going to be regulated at the municipal level. And so whether it's a building owner who says, I want to have a takeoff and landing location here, their neighborhood is going to need to embrace this, right? They're going to need to say, yes, I want this. It's going to make our neighborhood, it's going to be like having a new subway stop in our neighborhood. And so that's the crucial piece. And so we've spent the last 10 years, this has been my dream for 25 years. I built an electric VTOL in 1993. At that point in time, batteries didn't have the specific energy, that is the energy stored per unit of mass or per unit of weight that was necessary to get sufficient range. And then I waited until batteries improved about 10 years ago. They got to the point where I thought that the design closed, meaning that you could actually build a viable electric air taxi. And for the last 10 years, we've been doing very, very deep work on reducing the noise of the acoustic noise from the propellers. So one of the beautiful things about electric propulsion is that the motor itself is drastically quieter. And so with a helicopter, your two noise sources are the rotor and the main rotor, the tail rotor, and then the engine, whether it's a turbine or piston engine. And the piston or turbine engine is about half the noise of the helicopter. So the electric propulsion solves half of that. It also massively reduces the emissions and massively increases the efficiency. So there's a whole bunch of ancillary gain from a climate perspective there. But the key piece for community acceptance and being able to take off and land from locations that are convenient is this noise piece. So it solves half the noise piece. We've been spending the last 10 years really working on solving the other half of the noise piece, which is the noise from the propeller. And our target is to be more than 100 times quieter than a helicopter.
And isn't it also that you explained that as a piston shrinks, it doesn't have the same cost reductions and there's more dramatic efficiency reduction. Electric motor is a beautiful thing.
Yeah.
That it's efficient and you can shrink it and put it around different rotors, whereas you can't put little mini combustion engines on the 4 rotors. Did I get that right?
That's exactly right. So basically, an electric motor can scale from being a few watts up to being hundreds of megawatts, and you get relatively high efficiency. You can get efficiencies around 90%, and in some cases for larger electrical machines, you can get efficiencies that are up in the high 90s. Whereas with a piston engine, you move from small engines that have efficiencies in the teens up to large piston engines, which can have efficiencies in the 30s or 40s, 30 or 40%. Turbines, which small turbines are maybe 10 to 20% efficient, and large turbines can get up above 50% efficient. And so what that means is, because there's a huge scaling of efficiency versus size on pistons and turbines, it means that if you want to distribute the propulsion around the aircraft, you're going to take a huge efficiency hit. And that's the reason you see the commercial airplanes with going to fewer and fewer engines, right? And it's because you get more efficiency and you get lower capital cost to buy the aircraft, and lower maintenance cost with having fewer of them. A turbine on an airplane costs hundreds of thousands or millions of dollars to overhaul every 3,000 or 4,000 hours. And so that's a huge recurring cost that really was a big hit to the early helicopter commercial operations that Charlie was talking about.
I still like flying on a plane with 4 engines instead of 2.
Well, I was going to add to that
Vogelheim.
because, again, as you say, the engines become more efficient and smaller, then you can have more. Then you get the redundancy where you see the 4 corners of the aircraft. There can actually be 8 motors in this case out there. And then also by reducing the diameter of the blade, you're also making it a little bit less efficient, but certainly quieter in the process. So.
Yeah, so noise and weight are really closely correlated in the sky. So the bigger the rotor, the noisier the vehicle. So these Sikorskis that were zooming around San Francisco were spectacularly noisy because the aircraft could carry 16 passengers. Super, super heavy. So over time, we've gone to smaller and smaller helicopters, which get quieter over time, but fundamentally, you've still got this problem. Whereas if you're able to move to a system where it's distributed, you can bring down the cost of the aircraft and you take the weight of the turbine out, and you can make it much quieter with much smaller rotors.
And Uma and JoeBen, you have different visions in terms of the way this will roll out. Uma, that you think it'll be sort of urban hops, and JoeBen, you think it'll be more kind of suburban commuter. Paint your vision in terms of where you think this will adopt first.
So I think that one of the most interesting use cases is what you have in Sao Paulo, which is a place that is not really well connected in the urban environment. So the urban core does not have a lot of mass transportation. It does have a subway, but it's not everywhere. It's not ubiquitous. And so in a city like that, where you have the infrastructure in place to enable intercity commute, you can save yourself. So we used to fly from Paulista to Itaim. It took us 3 minutes, and it can take you up to 2 hours in a car if you catch it at the wrong time of day. And so from the airport to the city center was 12 minutes by helicopter and 4.5 hours on a Friday afternoon. And so you can radically cut out a lot of time out of your daily commute for the intercity urban commute. And you end up with a slightly different architecture than what JoeBen has on the suburban commute when you go down that route. And so there's about 30 cities around the world that can support an intercity transportation network. So Mexico City, Los Angeles, Sao Paulo, Lagos. There's these cities in the world where you could do this today, and it could actually work, and you could have a material impact on congestion in these cities.
JoeBen, you have a different view. The people are commuting 100 miles to their job?
So I actually think that Uma and I, we very much share Uma's view. We're designing our aircraft. It can do a 2-mile trip in a very, very heavily congested area, or it can do a 200-mile trip. And by building one aircraft which has a huge amount of capability and can serve all the different missions, it means that we're going to be able to scale up the production of them to larger quantities in less time and get the capital cost of building them down quickly.
What does this mean, though, if I can fly, if I can live 200 miles from work, you could live in Lake Tahoe and work in Palo Alto, that sort of thing. What does this mean for land use, for sort of live-work patterns, JoeBen Bevirt?
Well, there's certainly the example that you talked about. I think one of the things that gets me the most excited is thinking about the future in which we're pulling a lot of traffic off of streets in the city. And we can all of a sudden, if every other street got turned into a walking only zone and you planted trees and created parks, we've all been to cities which have created walking only zones, and restaurants go out onto the cities, onto the street, and the city comes alive in a really magical way. And so as I look at this future, that's the future that gets me really excited, is what can cities look like as we remove the automobile? For the more than 100 years, our cities have really become chained to the automobile, and our civilization has grown up around the automobile. But what if we can remove those chains? And what of our lives, what of our cities? How does the world look, 20 years from now or 50 years from now? And that's what gets me up every day.
But doesn't the flip side of that, doesn't it enable sprawl?
I think it enables people to live where they want to live. If they want to live in the city and still be able to work in the Silicon Valley, or if they want to live in the country and be able to work in the city, it provides people and it also it provides access to jobs that people don't have access today, right? If your dream job is somewhere where you're, that's 50 miles from where your partner works or your kids go to school, and they've got all their friends. Today that's a really, really horrible and hard choice that you have to make, where you have to say, okay, I'm either going to spend 2 hours in the car every day, or 2 hours every car, on the way to school in the morning, or on the way to work in the morning, and 2 hours at night, and I don't get to see my family, or that in order to have my dream job. And so a lot of people can't take the opportunities, don't have access to the opportunities that they like, because of where they live.
Certainly a lot of wasted productivity, although it's good when you're listening to public radio and you're sitting in traffic jams. If you're just joining us, my guest is JoeBen Bevirt, founder and CEO of Joby Aviation, Jennifer Richter, an attorney with Akin Gump in Washington, D.C., Uma Subramanian, CEO of Aero Technologies, and Charlie Vogelheim, an auto industry consultant. I'm Greg Dalton. Uma, how is this going to flow into commercial aviation? You used to work for a unit of Airbus. We're talking about an emerging niche sector. Global aviation is about 2% of carbon emissions. It's growing quickly. What are the chances that commercial aviation will be influenced by these technological developments?
So this might be a slightly unpopular view. One of the big challenges with commercial aviation is that battery technology does not yet have the power density to enable regional/long-haul aviation using electric technology. So my view on this is that we're going to get hybrid electric systems first. Everyone's working on them. Rolls-Royce just acquired Siemens' electric propulsion division to string together a hybrid electric propulsion plant. And the reality for aviation, for commercial aviation to go electric, is that we need the next step change. So whoever comes up with the next iteration beyond a lithium-ion battery is going to be a billionaire, because commercial aviation is waiting for it, desperate for it. But we're not there yet. We don't have the ability. You get to a point where the wait no longer makes sense on the commercial aviation side. So I think the tie-in between urban air mobility and commercial aviation is that urban air mobility will serve as a feeder. A lot of airports are kind of 18 to 26 kilometers from the city center, and you can cut out a lot of congestion with people going to the airport. But the technical evolution is pretty tough. So there's been a lot of companies that have tried electric regional aircraft, and it's just really hard to make the design close given today's technology.
There's a company called Ampere in Los Angeles that has a 6-passenger Cessna, recently tested it. They sold 50 of them.
So you can do it with a 6-passenger Cessna. You just can't do it with a 120-seat A320.
JoeBen Bevirt?
So my mission is to save 1 billion people an hour a day in their daily commutes, moving people around cities. but I also have a dream, and I have a belief that within the next 20 years we will remove carbon emissions from commercial air transport as well. So the technology's there, and so there are exciting things to come on that front.
Charlie, do you see it happening?
Well, again, the weight is a big consideration, and one thing about liquid fuels is you have less when you land than when you took off, and aircraft are engineered accordingly that you actually have a lower landing weight because you've burned the fuel in place. So you're going to have to build the aircraft a little bit different. I see the hybridization as being the key transfer point, and even with some of these smaller
So what does that mean? So it's like you take off electric and then you fly on
Take
liquid.
off with the turbine.
Take off with
Exactly.
turbine, and
So-
then
and then-
you cruise on electric.
Yeah.
Okay.
Because the
Either
turbine,
way.
you need the power. The turbine. So fossil fuels are the most power dense, most efficient form of fuel out there. Unfortunately, right?
Beautiful things. Yes, yeah.
And the reality is that you need the most amount of power at takeoff, and so you use the turbine to get yourself going, get yourself accelerated, and then you can cruise in electric flight. That's how the hybrid system would work.
Yeah, and there's an overlap. I mean, the same thing we see in the cars, where the two work together to get the vehicle in motion, and then once it's in motion, you need quite a lot less power to just keep it in motion. And then, of course, coming down is quite a bit easier. You don't need any power at all. Gravity does the work for you. So.
What did we learn from the business models of of ride sharing? Is there lessons to be learned from the ride sharing to be applied to this? I'm thinking about data sharing. Jennifer Richter. I mean, cities have a right to know. There's a big tussle over the data, right? Do you think that cities should have access to the data for these things, especially if they're going to invest in the infrastructure?
Well, with respect to any number of multimodal types of transportation that are being introduced in cities around the country, the cities are requiring that as part of the deal with the city in order to launch that particular type of transportation. So if it's scooters, they want to know, they want access to the data so they know where people are using them, where they're coming from and going to. So that's really part of the negotiation with the city, and making sure that the city is comfortable and excited about the opportunity and feeling that it will be equally available to people, all over the community as well. I do think that one thing we can thank millennials for is, this heightened connectivity, always being connected, and now this sharing economy that's evolved, which really started with them. That's really lending itself to accepting these different types of multimodal transportation options and the sharing of these options. I think this is a really exciting time.
Another area of government participation is zoning. Just the idea of where can these I'll call it a heliport because I'm old school, vertical takeoff, whatever. I've seen some pretty fancy photos out there. I think Gensler designed one for Uber in Dallas, which were there early out there. But Jennifer, what's the role of zoning in terms of, because that's where local governments will really come into play. It's hard to get any building built in a lot of cities, let alone something where there's things taking off and landing all the time.
That's right. Well, there are all different kinds of designs for these skyports that will develop. And sometimes they're reusing rooftops that already exist, and sometimes it's a brand new structure. But I mean, clearly, municipalities will have to be involved in where they feel comfortable allowing that kind of flight to occur. And that's going to be an iterative process, I'm sure, with local regulators, federal regulators, the businesses, and the community.
JoeBen, your thoughts on that? I mean, probably no coincidence that some of that early stuff is happening in Texas, more business friendly than California, perhaps.
Yeah, I mean, it's an incredible opportunity for the global real estate market. We think about real estate as a $230 trillion global asset class, and what are the effects on that asset class as you provide a new means of mobility? If I've had friends that have building in London, they put in a new tube stop, and their cap rates soared. I was leasing space in a building in Shenzhen. They put in a subway stop in the basement, and the rents doubled. So you have this really, really intimate tie between, you look here in the Bay Area, real estate that's a long Caltrain. is substantially more valuable, and the vacancy rates are much, much lower. So access to transportation, access to mobility, being close to a freeway off-ramp, these are all things that drive the value of real estate. And so now all of a sudden, every building has the ability to have access to this new nodal network that Uma was talking about. And that's insanely powerful. And it really opens up mobility from every rooftop. And it's hard to imagine from where we sit today, but looking back, there's these pictures of New York in 1908, and then New York in 1915 or something like that. And over a 5 or 10 year period of time, it went from all horse and buggy to all automobile. And I don't know that this is going to be such a massive sea change, but I do believe that it will profoundly improve the quality of life in and around cities in a relatively short period of time.
And Uma, do these business models I want to clarify that what I heard, I think JoeBen say earlier, is that they are based on humans flying them, whereas Uber and Lyft right now, basically they're trying to develop autonomous because they don't want to pay, they can't be profitable paying drivers, so they need robots to be profitable. Is that different here in aviation?
So one of the challenges of aviation as an industry is we're going to be short. So given mandatory retirement ages in commercial aviation, we're going to be short about 35,000 pilots year over year over year for the next 15 years. So there's an enormous opportunity in aviation in general, and then that is commercial aviation today. That does not take into account the pilots you're going to need for urban air mobility. I think that ultimately, like, the economics work. So even with a helicopter, you can make the economics work so that you can get to a journey price that's about 2 to 3 times the price of a taxi, and make the economics close on a per seat basis. My former CFO is sitting there looking at me with a smile on his face. So it is hard with passengers in the aircraft and with a pilot in the aircraft, but it's not impossible.
So, okay.
So,
yeah, I was going to say
Charlie.
considerations have to do with weight, because the pilot weighs something. Training, again, they're much more valuable because of the effort that they've made to become licensed. And to your point, they're just going to be in short supply. And those that are well trained and safe should be flying hundreds of people around, not 3 or 4 people around at a time, unfortunately.
So when you compare it to the driver in your Uber or Lyft who's driving one person around at 20 miles an hour, a little bit of the time, you compare that to a pilot who might be flying an average of 2 or 3 people around, but doing it at 10 times the speed. You then end up with something on the order of 20 or 30 times the productivity for that pilot compared to that Lyft driver. And so that becomes really transformational in terms of when you think about what you can afford to pay that pilot compared to that car driver, because that on a passenger mile basis, it's profoundly more, that person's profoundly more productive. And so that's the way the economics close, where we can charge the same price, pay the pilot way more than they'd be getting paid if they were driving in a ground vehicle, and have incredible operating margins.
And to your point, when you talked about the congestion from Uber and Lyft from the shared vehicles, it is true, and because so many of their trips have 0 passengers when they're going empty to go pick somebody up, where when you're doing point-to-point transportation, you always have passengers in play, or you should most of the time.
We talk here a lot about at Climate One about economic opportunity, economic disruption, and the transition from fossil fuels to clean energy. What kind of jobs will be created? I'm thinking lots of highly technical jobs. So let's talk about job creation in terms of what job doesn't exist today that will exist in 5 years because of this transition.
Well, so I think pilots in general. So I tell a lot of young people, go be a pilot. It's a great opportunity right now. We're short pilots in the commercial space. We're going to be short pilots on the UAM side as well. And there's an enormous opportunity to learn new kind of air technologies. We also found that we ended up creating a lot of jobs. So just our Sao Paulo operation ended up creating 20 to 30 jobs with people that were on the receiving end of the nodes. So you have the concierges and the firemen and the people that are creating that are welcoming the passengers on either end, doing dispatch and
full-time fireman. I'm not sure that gives me confidence.
Yeah, That's one of those. It's a helicopter challenge, which you won't have with electric VTOL. But you've got job creation at the nodal network as well.
So there's service centers, there's people,
service
there's
centers,
sort of a
customer
lounge, people serving beers at the skyports, that sort of thing. JoeBen, what other kinds of jobs?
So, I mean, to date, we've hired 350 technicians and engineers, and we have hundreds of job openings and growing very quickly. As Uma talked about, we're going to need to hire thousands and then tens of thousands of pilots. There will be maintenance staff. There will be customer service staff.
Manufacturing in the U.S. or manufacturing overseas?
So we're setting up a production operation in Marina, which is at an old Army base near Monterey, here in California.
Monterey, south of San Francisco.
Yep.
Okay.
Thousands of manufacturing jobs.
Jennifer Richter?
And UAS Service Suppliers. So I mentioned earlier UAS traffic management.
UAS being?
Unmanned aircraft systems. So the air traffic control systems that govern manned aviation today will not be used for this lower to the ground unmanned system opportunity, whether it's for drones at lower altitudes or urban air mobility at higher altitudes, up to 3,000 feet or maybe even higher. So a whole air traffic management system needs to grow up to support this. There are a number of companies that are already doing it through a program at the FAA called LANCE. It's sort of a precursor to what this ultimately will be. There will be tremendous demand and need for having a number of these UAS service suppliers in the market that are assisting all the people that want to fly drones, whether they're carrying passengers or carrying packages or passengers, in order to ensure safe flight.
Jennifer Richter, how do we know that these things aren't going to be turned into weapons?
Great question. We don't. We will have a cooperative system, this remote ID and tracking system that ultimately will be a requirement for all drones, will be a cooperative system. And so the thought is that if someone is not cooperating in the system, if they have nefarious intent, perhaps you won't see them, in the system the way that you would need to, and you would know as law enforcement that you might need to take that particular drone out of the sky. Today, the authorities to be able to take a drone out of the sky are slim. There are aircraft, and it's a federal crime to take an aircraft out of the sky. So
I can't shoot one down over my farm.
You may not.
It's pissing me off, right?
You may not. Yeah. So we're working on that. That's one of the many things we're working on in Washington, because today the Department of Energy, the Department of Justice, the Department of Homeland Security are really the only agencies that have the authority to be able to implement counter-UAS technology. And what I envision ultimately, because there are so many verticals of critical infrastructure that may want to protect themselves from potentially nefarious drones, ultimately there may need to be some sort of system put in place, and I'm not sure who runs it. Maybe it's the Department of Homeland Security, where they can authorize certain individuals in organizations that are associated with critical infrastructure to be able to operate counter-UAS technology, and perhaps they're also specifying the kind of technology to be used. But there are lots of questions around the counter-UAS.
And I think one important thing is NASA's running a holistic system-wide safety initiative, and it's got multiple verticals and multiple technical challenges. And I think the answer on how you're going to actually protect the airspace is there's going to be a mandatory piece. So the airspace will be fully mapped is the ultimate end state vision. And the no-fly zones will be very clearly articulated probably in a collective piece of software that will be mandatory for any autonomous system flying in that. So there will be just paths you cannot go down. So do not enter signs that the system will not be able to manually.
Military bases, obviously,
Sure.
all sorts of
That's
things.
the notional construct at the moment. And the challenge with airspace management, and this is one of the big kind of hurdles to getting to autonomy is that a lot of the systems are quite analog. And so evolving from a system where you have an air traffic controller who like moves an aircraft along to a system where the system itself is doing deconfliction is a long and complicated road. But ultimately, in order to enable the system at scale, you're going to have these mandatory pieces of software that enable deconfliction.
And Greg, just to your point, also the cybersecurity developments in the autonomous vehicle side are going to transfer over. It's, again, any vehicle in motion could potentially be of danger. And obviously some are on the ground and some will be in the air. And obviously we've seen them used in both places. So it is a concern, but again, the cybersecurity side of the business is flourishing. And again, trying to stay a step ahead and make sure that the communications remain positive.
I think one of the things that we don't do in aviation enough is celebrate the safety. Aviation is spectacularly safe. It's thousands of times safer per passenger mile traveled than any other mode of transportation we have. I'll just let that sink in for a second. It's thousands of times safer. It's like one of the safest things you can do. And I don't think aviation talks enough about it, right? Just how spectacular accomplishments have been. Aviation used to be more dangerous, but every year for the last 100 years, we've made it safer and safer and safer. To now, it is our safest mode of transportation by a very wide margin. And so that's what we're aspiring to as we build these aircraft, is to provide levels of safety that aren't currently available in your daily mode of transportation.
But the 737 MAX 8 was an example of innovation going perhaps, or automation gone awry too fast with poor government oversight. So what does the MAX 8 tell us about going too fast or going?
I think the industry has learned a lot from that in the short term, but I think JoeBen laid out a vision where we're going to move from piloted to single pilot to pilot in the loop, but maybe not in the aircraft, to fully autonomous. There are vastly differing views. Even within Airbus, there's vastly different views. There's people that say you cannot have urban air mobility at scale without having autonomy. And there's other people that say, yeah, you can have it with the JoeBen, and I agree on this point, that you can have it by having pilots in the loop. But I think you're going to see an evolutionary process over time. The reality is you could fly an A321 if you have the right infrastructure at an airport. You could fly an A321 autonomously from Toulouse to San Francisco, no problem. But there's a public acceptance problem where very few people, I used to ask this question, who would get in an aircraft that's autonomous? And the answer is not many, actually. And so there's there's an evolutionary path here. And so the likelihood is you'll see piloted to single pilot to pilot in the loop. So similar to how you fly a Global Hawk today, where there's a human in the loop, to fully autonomous over a 20, 25-year period.
And by the human in the loop, you mean a human somewhere else controlling the remote control of the airplane that I'm in? And
right.
Okay.
Another piece is that it's really imperative that we do very, very rigorous engineering on safety and redundancy. Small airplanes today fly around with many single points of failure. Hundreds of single points of failure on a small helicopter. Unfortunately, the 737 had a single point of failure. Most commercial airliners do not, but it's imperative that we design aircraft with 0 single points of failure. And that's the way you achieve spectacular safety.
We're going to include your questions. So there's a microphone back there. I invite you to join us with one-part comment or question. Please briefly identify yourself, and we'll get through as many questions as we can here. And crisper better. And if you're just joining us, we're talking about the future of flying cars at Climate One. I'm Greg Dalton. My guests are JoeBen Bevirt, founder and CEO of Joby Aviation; Jennifer Richter, an attorney with Akin Gump in Washington, D.C.; Uma Subramanian, CEO of Aero Technologies; and Charlie Vogelheim, an auto industry consultant. Welcome to Climate One.
Thank you. It's very exciting to hear your visions and the potential. I've been watching it for a long time. I've been involved in aviation for 55 years as an amateur. But how does the climate change and the possible expectation that at least 5 airports in the Bay Area will disappear underwater, and how does that climate change expectation affect your vision of the future of aviation?
Who'd like to tackle that one? Although I think the Army Corps of Engineers can protect the runways. Whether they can protect the freeways getting to the airport is another question. But who'd like to tackle that? JoeBen Bevirt?
Hopefully, the rooftops will stay above water for a little while. But in all seriousness, we have to remove carbon from our aviation, and it's just essential for the future.
Flight shaming is a thing now. People are getting shamed in Europe for flying. And Greta Thunberg, the Norwegian climate activist, is on a sailboat to America now because she won't get on an airplane.
So I need to give her a zero carbon way to get from Norway to here.
Next time she could take a drone instead. But let's go to our next question. Welcome to Climate One.
Thank you. Hi, my name is Nancy Woltering, and I wonder what kind of design considerations have gone into protecting bird life, particularly around our shorelines, if we have hundreds of these around the bay?
So I'll take that one. The first use of our autonomy sensors will actually not be for autonomy. So these are the radar, the LiDAR, and the cameras that we put on the aircraft. They'll be for detecting birds and drones so that we can avoid them. They don't want us to hit them. We don't want to hit them. We're all unanimous on not wanting to take out birds. So if you look at wind turbines, which I'm a huge fan of, one of the things that I hate about them is, especially in the early days, the ones that went up in Altamont, my best friend's grandfather founded U.S. Wind Power. They were small, they were spun at high RPM, and they were very, very dangerous to birds. And as wind turbines have grown in size, the number of bird casualties have dropped. But it's really, really imperative as we try to solve climate change that we don't have collateral consequences. Thank you for your question.
Welcome.
Hi, Jennifer, you mentioned that the air traffic control systems are going to be different for unmanned, package delivery type drone aircraft than they are today. Why is that, other than the obvious, well, some aircraft are big and fly high and some are small and fly low to the ground? Isn't it sort of the same problem?
It is. The FAA, notwithstanding its sovereignty over the airspace, doesn't view its role as implementing and running an air traffic management system for aircraft that are lower to the ground. So as much as they will be involved in helping us with the rules and protocols that will be acceptable for this UAS traffic management system, which really is a cooperative system, they will not be running that system. They've been pretty emphatic about that from the start.
Yeah, I can add, having worked for the FAA, again, there's a lot of things that can be done with the sensors and again, with avoidance in a broader area, well mapped, as you mentioned, Uma, that don't require, human intervention to avoid collision. And that's the main purpose. And the speeds are a little bit lower and the controllability is at a much greater degree also.
And I think just the order of magnitude, right? So like we fly a few thousand flights a day in international airspace in the aggregate. And so what we're talking about is tens of thousands of flights a day, and it's just an order of magnitude problem, and it's materially harder. And so to go, and the system is truly analog. If you go sit in the control tower at SFO, it's fascinating. This is San Francisco, and the tower controllers still pass pieces of paper between each other to manage the flight as it's coming into the airspace. That doesn't work with thousands of aircraft in the sky at the same time. And it's just one of those things.
There also is an issue with respect to are we using aviation spectrum bands? Are we using aviation technologies in order to accomplish safe flight for smaller aircraft, lower altitude, or are we using other resources? And the fact is there just isn't enough aviation spectrum or the right technologies available or that can handle the volume, to Uma's point, of the interrogations that will be coming. And so we have to look at other more commercial solutions.
Next question. Welcome.
Gary, Malaysian. I'm curious about your comment. What would happen if Elon Musk gets his Hyperloop operating? These systems seems like they will all be archaic, airports and flying cars, etc. It seems to me traveling in tubes is much more efficient and less imposing than what we're discussing this evening. Anybody want to talk about that?
Well, I'd love to
Yes.
jump in just saying, the cost of a tube is way up there. Right now, one of the advantages to urban aviation is there isn't a cost beyond the actual building of the aircraft itself, certainly a landing place and things. But one of the advantages to the tubes, and even underground, unfortunately, and I love the term boring because I find it more boring than what we're talking about, is that the weather is consistent also. And we haven't really talked about that very much. I mean, again, talk about living up at Lake Tahoe, there's a lot of days that you won't be coming to work if you're in a small
That's fine with me,
aircraft.
yeah.
Well, yeah, I know. That's why you moved
Powder
there.
days.
So it is interesting, and the speeds are even that much greater with the Hyperloop. So it isn't just Elon. I mean, he's doing the boring, but it's Virgin is working on that and a couple others. So it's interesting. It's again one of, as we mentioned, one of the many solutions that are out there that we need to think about.
Yeah, so there's two aspects there. There's the capital cost you mentioned. There's the other aspect, which is it's a linear. It's like rail. It's linear, and so it's only people who are where your destination is along that line where you're able to be served by it. And because of the high speeds, it means that the number of places it can stop, just like on a train, are limited, and the cost of each of those stops is very expensive. The nodal aspect of what we're building here, if you have 100 takeoff and landing locations and you add another one, you all of a sudden have 100 new routes, right? And so it's really, that's the whole aspect. That was what was transformational about the internet, right? Was that network effect, and that's what's so transformational about what we're trying to do here. That is fundamentally different than something like Hyperloop, a linear 18th century methodology.
Next question, welcome.
Yes,
one,
I'm
no.
Jerry Baszler. I'm a private pilot, and I'd be curious to hear what your comments are in terms of how that will link to your type of system. What sort of freedom will the general aviation pilot have, and the consequences of just going out and flying for a day?
So the evolution of the airspace is going to be slow, right? And so we are not going to get from a world where you have pilots fully in control of the aircraft to something that's autonomous at any point in the near future. So I don't think it's going to affect general aviation that much. I think what you're going to see, though, is that in order to achieve JoeBen's vision of thousands of vehicles in a city, those systems are going to be materially less intensive from a pilot training point of view. We can't take, a year and a half and $15,000 to get a pilot to his PPL, and then, need him to have instructor rating, and then commercial, and then whatever else it is to carry passengers. It's just too long, and it's too many flight hours, and it's too expensive. So the systems themselves for electric VTOL will be materially different than a general aviation aircraft, but it shouldn't affect general aviation.
I think you're asking about, again, just being able to go out and fly and have some fun without all of these going on. Likewise, a pilot, it'll be there for a while. There'll be controlled airspaces. Again, most of it will be, around urban centers, and then some of the links between. It'll be interesting to see what it means here in the Bay, because we have, again, so much of a broad array of destinations and routing that we can take, that as we have right now around airports, you'll probably have similar controlled airspace, at least in the development time.
But there will be integration between this UAS traffic management system and the ATC system.
Next question, welcome.
Thank you. Katie Hansen. Charlie, I really enjoy your radio show, and I'm wondering, as you are covering the automotive industry, are there any car companies that are taking to the air?
There's been some interesting design things, and when you talk about car company, I mean, because we talk about, and you mentioned Airbus, Boeing, of course, is taking this very seriously. The car companies, Daimler is behind the Volocopter, and I know Uma can speak to that. That's, of course, the company in Germany. And then, of course, Audi is doing a great Intel design with, help me, with one of the Boeing aircraft that they're talking about. But they're talking about, again, the integration of the aircraft, like a pod, which, again, this is now really really cool, where you get into a pod that's in a car, and then it pulls up to something, and then the a helicopter or the blades are attached to it, and then you take off and fly somewhere. Then you're dropped back down into a car-like structure. Audi Intel design. Look that one up, and you'll learn more.
And it's an Airbus.
That's Airbus. Thank you.
It's actually not Boeing.
A3, that was it.
So the actual flying module was an Airbus Audi Ital design.
But the interesting thing that people keep thinking about when they think about flying cars is where's that car that I can drive, and then the wings come out. And again,
Chitty chitty bang bang.
well, chitty chitty bang. You say the Jetsons, and I say that was a spaceship, not a flying car. But again, that takes runway, that takes infrastructure. What you basically have is not a very good airplane and not a very good car at the same time. So
Henry Ford, 1940, said flying cars are coming. Famous quote. Let's go to our last question.
I was wondering if you could comment on biofuels and alternative fuels as another route to reducing emissions, particularly for commercial flights, where, as you mentioned, the energy density of batteries just isn't high enough.
So I think biofuels and other aviation fuels made from organic materials is a really interesting trend. So there's a company actually in Fremont that takes household organic waste and makes Jet A1. It's a company let's see if they're able to scale their technology, but it's a fascinating path. And everyone is working on, so all the major OEMs are working on biofuel alternatives to commercial Jet A1. And I think that's one of the most interesting trends. You still have the emissions problem, but you don't have the sourcing problem that you have with conventional fuels.
And they're blending that at San Francisco Airport, but it's like 1% or something. United's doing that. It's tiny, but
it's the cost actually is really high at the moment for biofuels. But if you get to this point where you're like taking yesterday's dinner vegetables and making them into Jet A1, all of a sudden it's a materially more interesting value proposition.
right, fulcrum.
It's a lot of vegetables.
It's a lot of vegetables.
yeah.
We're going to invite you to a reception outside where we have some vegetables, organic. Please eat them all. I get the honor and pleasure of sitting up here with these fascinating guests. It's the Climate One crew that makes this happen. So let's give them a round of applause here for. Today's program has been underwritten by our friends at the Climate Works Foundation. We've been talking about flying cars and how they may change personal mobility. The technology is developing faster than many people realize, but it remains to be seen if it will receive public acceptance. I'm Greg Dalton, and my guests today were JoeBen Bevirt, founder and CEO of Joby Aviation, which is building a new 5-seat aircraft that runs on electricity. Jennifer Richter, an attorney with Akin Gump in Washington, D.C. Uma Subramanian, CEO of Aero Technologies, a startup company focused on next-generation air travel, and Charlie Vogelheim, auto industry consultant and co-host of the Flying Car Radio Show. Podcasts of this and other Climate One shows recorded with a live audience are available wherever you podcast. Thanks for joining us. We'll see you next time, everybody.
That was awesome.
Thank you. Come on back. Bye.